So we mentioned the importance of design in the checks or test automation. There are two design considerations. On one side we have code and project structure. We have to follow the rules for good code. And on the other side we have test design consideration. What kind of checks will we perform? So in the code and project structure we have to think about the code, about the practical code of the checks automation. It needs to be robust, it needs to be configurable, independent, rich in results reporting. As well, we have to think about the overall code quality. Who is good in coding? Well, developers are good in coding. You can ask them to help you refactor, to help you design good test automation. In the test design part, we have to think about what will these checks do with the application under test and where are we going to focus our automation. Are we going to use the data-driven approach or BDD, basically a keyword-driven approach? Are we going to use self-explanatory data approach? Are we going to use the checks as a safety net? Which is the information objective of the checks? Is it going to be a regression and we can use some regression testing heuristics or anything else? Those who should be good at this part of the test design are testers. Let's talk about robust design. Having brittle tests that require too much of the maintenance will quickly eat up our time. We have seen the examples of the companies who had too brittle tests that didn't design their tests to be robust enough, and they completely forgot about the idea of the automation. They actually claim that automation is useless. Well, just because they did it wrongly, they did it bad, maybe they had bad approach or lack of experience, or maybe just they applied the automation in the part of the application that was not supposed to be automated. And therefore they decided, oh, the whole thing about the automation is wrong. Well, this just proves that they didn't understand the automation in testing. Therefore we have to design our code and checks so that we are sure they can be executed in most of the conditions. So if it's a graphical user interface, what happens if the control we are interacting with changes its position? Therefore our application should be testable. That means it should have ID or some kind of identifier that is unique in that part of the application. What happens if we change the environment? Are we able to run our checks in each and every environment we can think of? Maybe we should think about that. Maybe it's not important. Maybe it's enough with a test or pre-production environment. Can we run it on all browsers if it's a web? And usually nowadays it is a web. Can we run it on Google, Chrome? Can we run it on Firefox or even on Edge? Those are the considerations we have to have in mind when we try for the robust design. The main thing we have to think when we are thinking about this is we need to minimize the need for the maintenance, because maintenance is the common overlooked overhead in the automation. Can we trust our tests? Can you trust the checks you just automated? What happens when we receive a failing automated test? Well, what we usually do is rerun it again to see if by some kind of magic now it works. And it's quite common. And it's quite common that it actually passes, because it was a bit brittle, but we were not able to take care of this brittleness. And this raises another question. If we don't trust our checks when they fail, why do we trust them when they pass? Maybe we should not trust them if they pass. If they are bad enough, we don't trust them when they fail. Maybe we should don't trust them when they pass. A good idea while we perform the implementation of the automated checks is to make them fail in many ways before we are happy with it and before we say, okay, now it is passing check and I'm quite happy with it because I know that the failures are going to be real failures and not just some false ones. Another interesting practice is to add logs and screenshots to test results and then analyze the test results. If we see a screenshot that says there was an update in the Windows, we know, okay, it's not a failing test. It's just not the application that's wrong. There is a bug in the application. The system is wrong. We have to consider the independence of our checks. when we perform so-called manual testing, we can use the skills of observation to decide on the results. We can do experiments and decide the following experiments about that. Because the previous state of the application affects the result of our test. Automated checks don't have such ability. They do exactly what they were programmed to do. So we should go for the independence. Every automated check should be as independent as possible in terms of dependency of data, environment, or previous checks. We don't want to have a previous check mess up with some data for the next check and the next check fails. Or we don't want to have the check B dependent on the result of the check A, because if the check A fails, then the whole purpose of the check B is lost. It's a good idea to use test setup and test cleanup to bring the application to a desired state in which we can start the automated checks. And the last part and the important part in this chapter is the use of exploration in automation. As we mentioned, the exploration is all about learning, about getting information, about performing experiments, and this is especially useful when we design our automation. So a good deal of automation is about making decisions. What are we going to automate? Which part of the application? How are we going to design? Which techniques are we going to use? How are we going to get this information? Well, quite easily. Let's just explore the requirements, explore the project context, explore the documentation and the application under test, explore to see if you can automate it easily or not, and then make your informed decision based on all that exploration. When we lack this information, we may take wrong decisions, and wrong decisions in automation are often quite expensive.